Hello guys, my name is Andres Sava, and today we'll be discussing the experiment of phase changes using water. The material that we'll be using for the experiment is just a couple of bottles of water and a freezer. What is a phase change? A phase change, or a phase, is a fancy way of describing what state of matter something is in. The states or phases that occur every day are solid, liquid, and gas. In solids, atoms and molecules have less energy than liquids. The atoms and molecules are closer together, allowing for a definite shape and size. Liquid molecules hold more energy than solids but less than gases, giving them more fluidity of movement. These usually take the shape of their containers since they don't have a definite shape of their own. Gases have more energy per molecule or atom than liquids. They have no definite shape no matter the container. A phase change is the process of a substance gaining or losing energy so that molecules or atoms either come closer together or become farther apart. When a solid gains enough energy, it becomes a liquid. When a liquid gets enough energy, it becomes a gas. When a gas loses energy, it becomes a liquid. When liquid loses energy, it becomes a solid. There are times when a solid gains so much energy it skips the liquid phase to jump straight to gas and vice versa. It is important to point out that phase change is a physical, not a chemical change. The substance still has the same chemical characteristics. The kinetic model states that the molecules that compose a substance are in constant motion due to the internal energy possessed by the molecules, and that there are three different states or phases of matter, as we said earlier, which are solid, liquid, and gas. The physical state or phase is determined by the relative strength of the molecular internal energy and the energy of attraction between molecules. At low temperatures and low internal energy per molecule, the energy of attraction is stronger than the internal energy, and the molecules bond together to form a solid. The molecules in a solid can vibrate, but they stay in a fixed position. At high temperatures and internal energy per molecule, the internal energy is similar in strength to the energy of attraction, which changes the bonds between molecules so that the substance can move more freely as a liquid. In a liquid, the molecules can vibrate, rotate, and move around, but they remain in close contact through chemical bonds. Liquids therefore have fixed volumes but not fixed shapes. At high temperatures and high internal energy per molecule, the internal energy is stronger than the energy of attraction. The bonds between molecules can break and the substance is in the gas state. In a gas, the individual molecules are not bonded together, so they can move about freely in space in addition to rotating and vibrating. Gases do not have fixed volumes or shapes and thus take on the shape and volume of the container holding them. What are the factors that affect phase change? Factors that cause phase changes in matter are pressure and temperature. A phase change is when matter changes to form one state, solid, liquid, gas, plasma, to another. These changes occur when sufficient energy, as we said earlier, is applied to the system or a sufficient amount is lost, and also occur when the pressure on the system is changed. So in this diagram, we have a phase change diagram that we are going to explain. So the temperature, heat, as well as pressure determine what phase, either solid, liquid, or gas, a substance will be in, as we said earlier. The triple point is the point where a pure substance will be a solid, liquid, and vapor all at the same time, or the point where all phases will coexist. Each substance will have a unique triple point. The critical point is the end of the phase curve and where the phases become indistinguishable from one another. In other words, the boundary between liquid and vapor disappears, the pressure and the temperature both reach a critical level. The substance is now a supercritical liquid. The importance of a phase diagram is not that with some practice, the phase of any substance can be predicted given a certain set of parameters. At a substance's melting and boiling point, the temperature and pressure do not change, but the state of matter does. As energy is added to a system, it is absorbed by the molecules of the substance rather than the system itself, causing the phase change. So in this experiment, as I said earlier, we're going to use a few water bottles and a freezer in order to perform this experiment and explain phase change of water. So I left 5 bottles of water in a freezer for 2 hours and 45 minutes exactly, and this happened. Took out the water, which was you saw that the water at first was a liquid, and the point of the freezer was to reach the right temperature right before the liquid water turns or changes phase into solid. By heating the bottle, I apply pressure. I change the pressure inside the water bottle, thus reaching or changing the phase of water from liquid to solid. As you can see right here, the water is completely frozen or solid. Here I try to create ice by pouring the water. I took the bottle from the freezer very carefully, but this one it didn't. You see that nothing happens because so this experiment was not successful. I also tried to pour some water in a glass and add an ice cube in order to change its phase from a liquid to solid. Nothing happened again. So in this experiment, I tried to put the water bottles in the freezer for less amount of time because I noticed some bottles started to creating solid inside the bottles and not only liquid. So I experimented a little bit with the hours that I left the water bottles inside the freezer. But as I said, I failed to do the other 2 experiments. So I took a video of how the experiment should look like. As you can see right here, the water freezes right away, creating like a little ice cubes, large ice cubes, as you can see right here, due to the change of the temperature. This is the other experiment right here, change of the temperature. We drop an ice cube inside the water, and the water freezes right away.